or it would be 10. So it would be 0.
So when you get a remainder of 0, that's a good thing. That means that it's a factor. That means that it worked. Okay, so
Okay.
it was minus 1x cubed plus 6x squared minus 3x minus the constant there. What is the new thing as a result of this?
Like, oh, -1x cubed.
Nope, because when you divide, it goes down by a degree. It goes down by a degree, so it's no longer x cubed. It's now an x squared.
Oh, and then plus 1x.
Okay.
What plus 2.
Plus 2. Good. Okay. So you ignore that. You don't. The remainder is not important. So now it's a little bit odd to have a negative in front of the x squared, so you factor out the GCF. So when you factor out a -1, tell me what goes inside parentheses.
Just get rid of that -1. So x squared.
Okay. What else?
Plus
You're
just
factoring
x.
out of everything. Everything. You're dividing it out of everything. It's when we say factor out, it's really like they call it divide and slide. You're dividing each of those by -1.
Okay. So is it x squared plus
You're dividing by -1.
uh what the heck? What even is 1 divided by -1?
Well, it's like changing the signs.
So it's still -1, right?
Becomes negative, yeah. What else? What else does it go with?
-1x
Okay,
plus -2 or -2.
very good. Okay. So when you focus on just the part inside parentheses here, you're going to factor this. You're factoring it into two binomials. So you're looking for
Okay.
two numbers that multiply the -2, but add to -1.
Okay. Let's see. I think -2 and 1.
So x plus 1, x minus 2. Bring that negative down, and then we had an x minus 5 from before. So this is considered factored form.
Hmm.
Seen that before?
Yeah.
Okay. So to find the zeros, find
Wait,
the
where's the 5 come from?
x-intercepts.
Where'd the 5 come from?
Question?
Where's the 5 from?
It's me giving it to you. I told you that x minus 5 was a factor.
Oh, okay.
Synthetic division, you reduced it down. So to find the zeros, the x-intercepts, the roots, all of these could be used as words. You set each factor equal to 0.
Okay. So just
What are the
make
zeros? Give me the 3 zeros.
okay. -1, 2, and 5.
Okay, very good. So now at some point we would start graphing this thing. We would say, okay, let me go grab a graph off the internet here. You could expect to do some sort of a graph. Find one here. All right. So I like to graph as you go. I don't like to wait until the end. So we found the y-intercept was 0, -10. And then we had -1, 2, and 5 as your x-intercepts. Now I'm going to tell you that this one starts high and ends low. We'll get to that, why that is. You gotta come down and connect something like that.
Okay.
Have you seen this before?
Yes.
Okay, so we're gonna do another example problem. You're gonna be more involved. You have some paper, you have a notebook,
Yeah.
something to write with. Okay, fantastic. So let me put one of those in front of you. I gotta make it up. So let me get where I can quickly do that here. All right, so let's go. I'm not gonna tell them to you. That wouldn't be too nice. All right. So this polynomial is x cubed minus 8x squared minus 9x plus 72. So go ahead and find the y-intercept for me, please.
Okay. Um, let's see. So 72.
Okay, so it's an ordered pair, right? It's 0, 72.
Okay.
All right. And then I'm going to tell you that one of the factors is x minus 3. Okay, so what goes in the box here on the left?
3.
Okay, and what numbers are used for the synthetic division here?
Um, 1.
Okay,
Minus 8. Minus 9. Plus 72.
so I want you to verify that there's 0 here, and I want you to tell me the numbers that go here when you're all done, please.
Okay. Uh, 4. Okay, I got it.
Great, what are your coefficients?
Uh, would the first one be 1?
Okay, the next one down here.
Um, -5,
Okay,
-24, and
what's the last
0.
one? Very good. Okay, so this becomes x squared minus 5x minus 24, and you have to be able to factor this. So you have to find two numbers that multiply to uh, -24, but add to -5.
Okay. Uh, uh, that would be -8 and 3.
So x minus 8, x plus 3. You bring the other factor down. What are the three zeros?
Um, 8, -3, and 3.
Very good. All right, so now we got to talk a little bit about end behavior. End behavior. All right, so there are four graphs you have to know to be able to do end behavior.
Okay.
right? And boy, these didn't really. Let's see if we get this a little bit. All right. So there are two things to consider with end behavior. First is the degree of the polynomial. The second is the leading coefficient, whether it's positive or negative. So for the first two, we're going to do an even and even degree. So even degree polynomials either start high and end high, or they start low and end low. Have you seen this before?
Yeah.
The difference is what's called the leading coefficient, which is A. If A is positive, you get the one on the left. If A is negative, you get the one on the right here. And then you
Okay.
get some words like as x goes to infinity. So that's this graph going to the right here. This part of the graph going to the right. It's rising. Rising means that it goes to infinity. And then you can go
Okay.
the other direction as x goes to negative infinity. That's to the left. That's one on the left here. It's also rising. So f of x also goes to infinity. We can do the same thing for this middle one, the second one here. So as x goes to infinity, that's the one on the right. The graph here is falling. F of x goes to negative infinity. As x goes to infinity, negative infinity, f of x goes to negative infinity. That's falling. Okay, so you are responsible for knowing all this, meaning
Okay.
you've got to get all this down. I'm going to ask you to refer to it as part of our lesson today.
Okay.
All right, so the next two are odd and odd. Odd starts low and ends high. The other one starts high and ends low. A greater than 0, A less than 0. And then we can write the end behavior here. Okay, so you are responsible for knowing all this. You can
Okay.
take a picture, screenshot. I'm not gonna, yeah, just get it all down. Teacher expects you to know this. You'll be tested on it,
Yeah.
things like that.
All right. I'm good.
All right. So we've looked at a couple of functions today. Let me go back and grab them. So we looked at one, so I can pull it up here. We looked at x cubed minus 8x squared minus 9x plus 72. The degree of this one, can you tell me that? What is the degree of this?
6.
It's the highest degree exponent. What's the highest
Oh,
degree exponent here?
okay. Just 3 then.
All right, the leading coefficient is the number in front of x in the highest degree exponent. What's the number in front of x?
1.
All right, so this is odd and this is positive.
Okay.
So see how that tells us which graph? There are two odd graphs, one with a positive leading coefficient, one with a negative.
That looks like
So which one
a
is it?
greater than 0.
Yeah, so the end behavior here, which is what we're going to need, is this and this. So then we looked at a problem where it has a function like this. It was a negative x cubed here plus 6x squared minus 3x minus 10. What is the degree of this one?
Oh, it is 3.
What's the leading coefficient?
Uh, -1.
So we have odd, we have negative. So if you go back to our reference, that's this one
Yeah.
on the right. So you go boom and boom, and you get it. All right. Any questions on that before we start working on some problems again?
Nope.
All right. Alright, so here is a new function for you to look at. All right, can you tell me the degree of this one?
4.
Degree is 4. What about the leading coefficient?
1.
It's 1. So which of these 4 graphs is it?
It is 1 even 1 odd. So it's odd. A is greater than
Which
0.
which of these is it? 1, 2, 3, or 4?
Oh, 3.
Isn't the degree an even number?
Oh, okay, okay. Let me look at my picture. Sorry.
So is
But
it
they're not
1?
both. They're not both. Okay, so it's number 1 then.
It is number 1. So if we were to graph this, we probably will. You need those arrows. Okay, so I'm going to tell you that a factor is x minus 5. And there's another factor x plus 5. Okay. So I want you to do the polynomial synthetic division, not polynomial division for for one or the other. Doesn't matter which one. Tell me what goes in the box.
Uh, 5.
Okay, so are you doing the first one or the second one?
The first one.
Okay, so give me the coefficients.
Uh, X or uh,
Coefficients are numbers. They have nothing. They're
sorry,
no, but
1,
no. 1, good,
2,
good.
-28, -50, 75.
All right, so go ahead and work this out. Tell me what goes in the last line. I'm gonna step away for 30 seconds. I'll be right back.
All right. Four, 9, 30, 31, 32, 34, 37. 35 again. 40, 50, so 15. 30. Okay. Okay, I'm good. You're there.
How'd you do on this one?
Pretty good, I think.
What do you got here for your numbers here?
I got 1,
Okay.
7, 7, -15, and 0.
Okay. So the nice thing with static division is you can actually just keep going with the next one. 1, -5, -10, -3, 15, and 0. So this becomes x squared plus 2x minus 3. Could you try factoring that for us, please?
Oh yeah. Do you just factor 1?
Nope. You're doing what we did. Let me show you because you've done this a couple of times now. You did the factoring right here for this one, and then you did the factoring. I guess we didn't have you do it in the other one. How'd you do it right here? So what did we do here? What were we looking for?
To get I guess like x by its so or I don't know.
Two numbers that multiply to -24, but then add
Oh, right,
to.
right, right, yeah.
Okay.
Okay, I know how to
You
do
were
this.
there. That was what I was trying to show you. You did that. Like I didn't do that. You did that. So you gotta do
Yeah.
the same thing here.
Okay. Just -3 times 1.
What goes in parentheses here?
Um, x minus 3 times x plus 1.
Okay, and the other factors we brought were these down here. Could you give me the zeros, please?
Yeah. 3, -1, 5, and -5.
All right, so we said earlier the degree was 4 and the leading was positive. I'm gonna draw 4 arrows, and you're gonna tell me which of these we're keeping for degree 4 and leading coefficient positive.
Okay. I believe, let's see. Yeah, so that's number 1, like both
Right,
even.
so which of these 4 arrows are we keeping?
Oh, sorry, A and B.
Okay. All right, and then so like not to scale, but you know, -5, 5, 3, and -1, you know, comes down something like that. So, oops, why did sometimes that happen? So the expectation is that you can draw something like that.
Okay.
Okay, so we're going to increase difficulty slightly here. Let me grab a new problem for us to work on. How do you feel like your understanding is right now?
Mm, like I understand like all the I feel like I can understand like all the individual parts. I just have to like uh know like the order, I guess.
All right, so here is a new problem for you to do. And I'm going to tell you that x plus 2 is a root. So what goes in the box here? What goes in the box?
-2.
Okay. And what are the coefficients?
-2, 14, and 12.
You're missing a coefficient. What coefficient is missing? So remember, it's supposed to go down.
Oh,
It's
so
like,
thing
yeah,
squared.
yeah, so there's a 0 there.
Oh,
Okay, go ahead and work this out. Tell me what you come up with for that line below there, please. And the reason I made such a big deal out of that is if you didn't put this here, you wouldn't get 0 at the end and you'd wonder what to do.
okay.
Common test question.
Being a little tricky.
Yeah.
Okay. Um,
Got something for me?
yeah. -2. X cubed.
Okay, it can't
Um,
be, I'm not sure what you're giving me, but I just wanted the numbers
or
down here
X squared.
and it
Wouldn't it be
goes down by one, but yeah,
yeah, X
you can,
squared.
I'll take either, but go ahead.
And then for X,
Okay,
um, 6 plus 6, uh,
okay,
and then yeah, plus 0, I guess.
very good. So now the very first type of factoring you always do is what's called the greatest common factor, which could be a number or a variable, or it could be both. In this problem, you have a number. What is the number that goes into all three of these?
2.
So when there's a negative, you generally factor that out. So tell me what goes inside parentheses. Remember, you're dividing each of those by -2.
Okay, so X squared plus -2 X or minus 2X plus -3 or -3.
Good. Okay. Go ahead and factor this for us, please.
So it would be can you factor it and leave like the -2? Okay, that's what I was wondering.
Yes. Yes.
So um it would be X minus 3 times X plus 1.
Okay. And here was your other factor from earlier. And let me grab the original polynomial. All right. So I want you to make a rough sketch of this. You should label the x-intercept. You should have the y-intercept. It does not have to be to scale. And then the end behavior, like the arrows need to be going in the right direction. So you have enough here in this window to do that. If you need to, maybe go back to your notes. You can always ask me some questions. Take a minute or two and see if you come up with the right answer.
Okay. Yeah. So I know 12 is the y-intercept. Um, Let me see the x-intercept. I'm trying to remember how you find the x-intercept.
Well, we did it probably 4 or 5 times already. So do you have any notes from today?
I took notes on like the synthetic division part of that.
Okay. Well, I can tell, Jack, you're just a little, I hate saying this, maybe slightly disinterested this morning. I understand. But I already know all this stuff. So it's really up to you to figure it out. You get it written down. This is the factored form. These are the zeros. How did we go from the factored form to the zeros? What did we do here?
We just found what made them equal 0.
Exactly. Perfectly said. Can't say it any better than that. So what are you going to do here to find the zeros?
Um, well, let's see. You can do so there'd be -14, uh, -12, and
No, no, no. Where's the factored form? Line 1, line 2, line 3, line
oh,
4, line
and
5,
2.
line 6.
And 2.
Okay. So this is only here to help you with something else. What are the zeros from the factored form?
3, -1, and -2.
Okay. So you've got a y. It sounds like you've got these down. What do you do to get the end behavior? What are the two things you need from the function?
Well, the two things that we have.
Okay. And what are the two things that we have?
We have 12 and um, the x-intercepts.
Okay. So It feels like you missed this whole part where I said end behavior is based on two things, the degree and the leading coefficient. And then we made these four graphs. And then I even asked you to do a couple of examples, which you did. You were there, you did those. And now you're telling me you don't remember how to do it. So you
Okay,
need
so
the,
the degree is just 3 then.
okay. And the leading coefficient?
-2.
Okay. So that gives you enough to figure out where the arrows go.
Okay.
So
Uh,
I'm looking for you to do some sort of a graph. I'm not going to do it. I'll wait till you do it. When you've got one, then I'll do it. You have everything you need to graph this. Doesn't have to be perfect, just needs to be an effort attempt.
okay, so uh, it would be odd. Um, and let's see. Okay, would it be
Get something down on your paper. I will sketch it out for you as well, but make an attempt here. There's no
okay.
punishment, no crime for being wrong. This isn't North Korea, China. We're just trying to increase our knowledge here.
Uh, well, I have my little graph, I guess.
Okay, so here's what you told me. You told me the y-intercept is at 0, 12. Do you have something like that down?
Yeah,
Okay. Then there were intercepts at 3, -1, and -2. Do you have something like that down?
yeah,
Okay. And then you have to get the arrows in the right places. Okay. So leading coefficient negative, you have your arrows here.
yes.
Fantastic. Now it's just connecting. Doesn't need to look pretty. Doesn't matter to me. If your graph looks something like that, you get full credit.
Okay.
All right. Let's just do something like this real quick. X squared minus 7x plus 12 equals 0. Could you try? Sorry, that's not going to work. Um, could you try factoring this for me? Two numbers that multiply to 10 but add to 0. I'm sorry, multiply to 10 but add to -7.
Yeah. -5 and -2.
Right, very good. All right. Okay. So good close there at the end. I feel like you got some